So, okay, I'm just gonna start. Okay, so, uh, hey everyone, my name is Mohammed. Uh, I'll be your instructor for this. We'll be going over two pointers. Uh, has anyone here done LeetCode before? Yes? Okay, so you guys are probably familiar with what two pointer is, right? No. Okay, so we'll do that today. So, okay, so let's look at the problem. Um, Bigger? Yeah, yeah. Good. All right. So let's look at this. So DNA sequence symmetry, right? We're given a DNA sequence, and we have to consider whether it's symmetric if it reads the same forwards and backwards after we remove the non-valid characters and we ignore the case sensitivity. So given a string S, we should determine if it is symmetric, right? So these are the valid characters, A, T, C, and G. Okay. Okay. Some other people coming in. I'll just give it a second. But right. So let's look at this first example. So we're given S, which is A period. You guys see how it is, and this is going to return true. Why? Because after cleaning, what is this going to become? A, T, C, G, C, T, A. So it'll just be all the valid characters, and they're all just going to be converted to the same case. So in this case, it would be uppercase. It could be the same. We could make it lowercase. It doesn't really matter. And then we would just return whether this reads the same backwards if it and forward, right? So is this a palindrome, right? So, and in this case, it would be yes, right? So we would return true here. But then here in this example, we would get up A, T, C, G, C, T, C, G. See, like these this A and G are not the same, right? So they're not going to be the same forward and backward. So we should return false, right? So with that in mind, does anybody have any idea of how we might approach this?
So right off the bat, did we say that any odd input, or at least after we clean it, if it's odd, it wouldn't be a palindrome?
So you're saying odd numbers cannot be palindromes, like odd length.
Like any input with odd amounts would not be a palindrome.
Okay, so is there a jar like a this is Sharpie? I don't know if it's,
It's a Sharpie?
yeah, but let me give you the example like let's say it's valid. ACA is that so that's odd, right? Three is that a palindrome?
Yeah.
So it doesn't really matter whether it's even or odd, right? Like we could have ACCG, right? Like oh ACCA, that's even and that's palindrome. Thank you. So we could have that. I'm gonna draw here. If anybody can't see, just let me know. So okay, so we know that we don't really care whether it's even or odd, right? So first, let's just look at this, right? We have this, okay, and we want to end up with this. So let's think about the idea of cleaning it, right? So you, like I said, you guys are probably familiar with what two pointers are. So if you're not, let me just explain. This isn't like C++ pointers. This is more just like for example, right? So this is a string, right? What is a string? It's just a collection of characters, right? So like an array, right? So we can access each one with its index. So let's just give this example. Let's say we have this A, T, C, G, C, T, A. Okay, so basically we want to make sure, hey, so there's two ways we can go about this, right? We could reverse this and then we can compare it to this, right? And if they're equal, then we could return true. Or we could make use of the fact that a palindrome, basically the way a palindrome works is that if you were to like split this on the middle, okay, like split it down here, right? It's gonna look, if you look here and here and here, they're supposed to look the same, right? They have to have the same characters, same values. So we can kind of use that as an advantage, right? So let's say we only care about the indexes. So like, what would be the index of this?
0.
0, right? And what would be the index of this? So yeah, it'd be the length of the string minus 1, right? So 0, 1, 2, 3, 4, 5, 6. So 6, right? So let's look at this, right? So we have these two over here, and now let's just kind of move it in, right? So if ever they're not like if ever we move them in and they're not the same character, it's not a palindrome, right? So we can return false. So in this case, are A and A the same? They're the same, right? So let's move these in. So now we're looking at t. Okay, our t is the same, right? T is the same. We should move it in. Okay. C's are the same, right? So then we can move it in again. And now here we both get over here, right? And when they both get over here, like it's gonna be a palindrome, right? And now it's like it's valid. Okay. So then we can just return true. So this is with the clean string, right? But now let's say we're given this, right? Like this, like with a bunch of random characters that don't work. So A, T, and lowercase. So if we're given something like this, right? Using the idea of these two pointers, how can we basically clean this string? Does anybody have any ideas?
Like you remove anything that's not a letter.
Yeah, so let's just say like we encounter this, right? Like this isn't a valid character, so we can just like kind of go like, okay, if this isn't a valid character, if it's not A T C G, then we should just move it in, right? And then we can move it in from the left side, and then we can move it in from the right side, right? So like we can start over here. These two are valid, right? So let's move this in here, and then this pointer is going to be over here, right? This left pointer. This a valid character? No, right? So we should just move this in. So like while this isn't pointing to a valid character, let's move it in. So now in this case, it would just move how many times? Like what's the next pointer we'll move to? T, right? And it's gonna look, is T valid? T is valid, and then they're both valid. So okay, they're both valid. Let's move them both in. Okay. So now this is pointing over here, and this is pointing over here. Okay. This C, remember, we don't care about case sensitivity. We're just going to be converting all the letters to like uppercase or lowercase. But now this is over here, same logic, right? This is a valid character. Let's move this in. Okay. Here. So this is a lowercase c and uppercase c. If we were to just say if they're equal here, like that wouldn't be correct because they're like on the ASCII table, these are both different characters. So we would have to convert one to upper or one to lower. It doesn't really matter. So we can turn this into lowercase c. So this becomes lowercase c. Is lowercase c equal to lowercase c? Yes. Okay. And then like these pointers would then move in over here, and then it would just be a valid palindrome. So we could return true. So with that in mind, does everyone understand like what the algorithm is doing here? Any questions? No? Okay. So I guess we can just code out together. I'll just bring up a editor. Oh yeah. I'm gonna be doing this in Python, but I'm gonna try and make this as language agnostic as possible. So okay. So I guess actually before I do that, um, I'll just write out the pseudocode for everybody who doesn't want to do baby Python. Okay, so let's look at this, right? So do you guys know what a set is? So like how can we use a set here? Like what would be like advantageous of using a set?
Create a set of valid characters that we want to see.
Exactly, and like why not use an array or something?
Better at hitting multiple things.
Okay, okay, good. Does anybody else have a different answer? Exactly, right? Because let's just say we use an array, right? If we use an array, then we'd have to iterate through every single element in the array to check. And that'd be like you guys know what size time complexity is? Like the worst case your program will take to run. And it would be the size of the valid character. So in our case, it would be fine because it would be like O1 because we know how big the size is. But we can do it even faster, right? By using a set. Because a set, you can just instantly look it up, right? So it's really fast. So we can just talk about, right? So we can say, we can just say this valid characters, valid, okay, and then we can just say this is equal to a set. And like, does anyone have an idea what we should put in the set? Hmm? Did you say something? Oh, does anybody have a right? So it'd be our valid characters, right? So in our case, our valid characters. So let me just bring up the problem. Okay, so it would be ATCG. Okay, so I'm gonna do this multiple ways. So we don't care about case sensitivity, right? So we can put the uppercase and then we can also put the lowercase because I'll show you a bit later because when we convert it all to lower, it it doesn't really matter, but we can say these are our valid characters. Okay, so it'll just quickly look these up. Okay, so these are our valid characters. Okay, now with the ideas of our pointers. Okay, so where should we start our left pointer and our right pointer?
The left one would be the end, and the right one at the very end.
Right. So like what values should I put?
So the first one, in this case, would be a 0.
Right. And then what would right be?
The length of the string minus 1.
Okay. Okay. If I do, I'm just gonna define a function, the function of here. So I would just say solution, right? And this is gonna be taking in s, right? And it's gonna be s. I don't know. I think it's my bad. And this would be taking in a string s. Okay. And it's gonna be returning a boolean. Right? Okay. So we oh okay. So now we have our 2 pointers. So now let's think about this. Okay. Okay. So what is our program doing? How when at this point like should it stop running? Like so we're gonna be moving these pointers in, right? So at what point do we be like, okay, let's stop this program from running? We know we have the information we need to determine whether it's a valid palindrome. Right. So because the moment left, like we never want left to exceed right, right? If when that happens, then that means like, okay, left should never exceed right because I mean it's gonna then like it's gonna end up going off, right? So the moment left and right, like just like they get to a point where they're like gonna overlap, then we can just end our program because then we can find out whether there's a palindrome, right? So we can say, while so we can say while left is less than right. Okay, so now while left is less than right, what do we want to do? So let's first account for the case where the left pointer has an invalid character. So what should we do if we encounter an invalid character? We should get rid of it, right? So it'd just be like left plus equal. So let's say in this case we had like let's say here we had uh let's say we had something like this. So if we did something like this, right? So we wouldn't want to just do this once. We'd want to basically go, okay, while this isn't a valid character, right? We just want to move left in. Okay, so like while left is not in our valid characters, we should just move this in, right? But then there's also another case that I'll talk about. So there's that. So it'd be the same for left, and then it also be the same idea for right, right? Because everything we do for left, we should do to right. So before I write that down, right? Is there another case like is there something we should include that I was like talking about before in our while loop, our nested while loop for that for moving in the pointer for non-valid characters? Like let's say in this case, like let's just say we get over here for left, and then right is like let's say we keep on moving this in, right? But then let's just say right is over here, or like right is over here, like it'll end up exceeding it, right? So do you guys have an idea of what we should do account for?
We should break out before we get to that point.
Right. So we should just probably say like something like, okay, while like the left character is not in the valid characters, and then also while like left is less than right, right? Because we never want them to exceed each other. Okay, because the moment they exceed each other, then they can just keep on going and they'll just fall out of bounds. And we don't want that. So we're gonna say while left is so this is for the first main program. So then we can say here while so how do we access the character in the it would just be yeah, right? S left, not in so not invalid. Okay. and and remember our first case. So while s left is not invalid and left is less than right. Okay, so while we have these two cases, okay, what do we want to do? Any ideas? Increment left, right? So we just want to do left plus equals 1, all right? And that works for this, and then we could just do the same thing but for right, okay? I'm not going to write that because I feel like that's kind of redundant, so I'm just going to do this same for right, okay? So same for right pointer, okay? So now we have this for left, we have this for right. So now we have the case where it omits the non-valid characters. Now let's get to a point where, you know, we have the characters we care about, we want. What do we do? What do we do now? So now like we're let's care about this, like the first case, right? A and A, right? The point the pointers are gonna start there. So let's do that. So at that point, it's never gonna hit either of these, right? It's gonna, what is it gonna do? It's like, what are we gonna write?
You eliminate all the things that were invalid. Now we start checking it again to make sure it's a palindrome.
Right. So like, what would be the condition here? You remember, like I was saying, we could either turn it all lowercase, uppercase. So what would be the condition?
All the letters are uppercase.
Right. So yeah. So like, okay. So remember, I was saying we could either turn this lowercase a into uppercase, or we could turn this uppercase a into lowercase. It doesn't really matter. We just gotta get them to the same type, right? Like the same. So we can say, you know, like if, okay. So if s left, okay. So that lower, every language has like a lower function pretty much, but we can say if s dot lower, you know, does not equal s right dot lower, what do we want to do? They're not equal.
Turn one side to lower rated to make it equal.
Well, I mean, think about it. If this if this was if this was a e, right? I mean, is a and e equal? We'd want to return false, right? Because it's no longer a valid palindrome. So we can just, you know, return false, right? And then, so we have the left, so this is the invalid characters, okay? And this checks it. And now what do we want to do? After it let's just say it doesn't return false, what do we want to do with left and right?
Now we can go on to
Yeah, now we can just increment, right? So now we can just say left plus equals 1, right. What do we do with right?
or do the length minus one.
Yeah. Well, we just do right minus equals 1, right? So minus equals 1, because, you know, left is going in, right is moving in. So, okay, so this is good. And then after we pass this while loop and we've done everything, if it passes this entire while loop, it's a palindrome, right? Because now we've gone to the middle and it has a return false. So now we can just return true, right? Uh, does this make sense to everyone? Anybody have questions? And I'm sure like the people who've done LeetCode, like you guys caught on pretty early. This was, hey, this is, I know what problem, like, does anyone know what LeetCode problem this is? No? Okay, it's a really popular one. It's called valid palindrome. We can actually like just look at it here. It's pretty much the same thing, okay? But in our case, like, so okay, so let's look at this problem, okay? So we want to do, I'll let you guys read it. But so like in this case, right? It ends up just doing the same thing we did, right? But like here in our case, what here? So like, okay, what will we have to change to make it work for this problem? Oh yeah, I'll make it. Sorry. What'd you say? What do we like? What do we have to change? Like, do we have to change anything in our program to make it work for this?
Balance that.
The valid set, right? And like, what would the valid set become?
All letters and numbers.
Exactly. It'd just be, all the letters and the numbers. And the size of our set then would just be 36, right? Because, well, no, it will, we do, well, it doesn't really matter because we'll be converting everything to lower upper. So, yeah, we could say 36, like the letters plus the numbers, or like 26 times 2, 52 plus 10, which is 62. So it would be 62, but it doesn't matter. You could just do the lowercase. So, yeah, it would just be all the valid character. It would be all characters and letters and numbers. And then we could just, and this, everything here would just work the same, right? So that works for this. And the reason I changed up the problem was, first of all, to throw off some kids if they've seen the problem before, and also just because that's what companies love doing. They love changing up the problem. It's the same problem, but you have to recognize that. So yeah. Okay. Let's try the next one. Uh, let's look at this one. Okay, I'm gonna zoom out a bit because okay. So we're given a sorted array of canister weights, and our target weight is target, and we must choose two canisters whose weights sum precisely to a target, and we want to return their one base indices. Assume that there is exactly one solution. So another thing I wasn't showing, the constraints. These are like really useful. These usually tell you what kind of like how big, like what type of code you're gonna be running through the program. So if it's like, for example, if the uh, if the length, so like weights dot length, right? This is basically saying the size of the array. So 10 to the fourth, that's a pretty big number, right? So that means, okay, we don't want a crazy big runtime, like, right? We don't want like n factorial or something, right? We'd want to ideally get something that's like, O of n squared, right? So, okay, so let's just look at this. So if you guys didn't read the problem, so here, let's look at this. Our target, and this probably looks really familiar to you guys, right? Like, you guys have seen something like this before? Yep. Yeah. Okay. So, does anybody have an idea of how to tackle this? Yeah.
So for the output, the one based indices, don't indexes are at zero.
Yeah. There's zero. But it's like, for example, so in this case, right, it's 2 and 7, right? But when I say one based, I mean like just think of it as just plus one to each indice. So in this case, it's 1 and 2, right? But this is 0 and 1, so it just plus one. So that's fine. Okay, does anybody have an idea on how to approach this? And we can do this multiple ways, right? There's you could use a hash map here, but like you guys know the original two-sum problem, right? So you guys know the hash map solution, right? So like we could use that. Like our time complexity would be O of n, space would be O of n, but we don't need to do space O of n. We can actually do this time complexity O of n, and then space is O of 1 because it's sorted. Okay, so using the fact that it's sorted, how can we solve this? Like I'm looking for a specific. I'm looking for a time complexity of O of n and a space of O of 1, and how can we use that? Like using two pointers.
Depending on how large our target is, we can skip certain numbers and not have to look at them at all.
I so what you're talking about kind of is like binary search, right? And yeah, we could do binary search on this problem, right? But then what would our time complexity be if we did binary search here?
Would it just be O of n because you search under?
So 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 right. So it'd be n log n, right? Because first of all, so this one's two numbers, right? So the way binary search here would be used, like let's say we start at 2, right? Then we'd have to do binary search from like this window, right? And then we could do binary search here. So then we'd have this first number. The first for loop would just get the number, and then the second part, okay, that would do binary search on the rest of the array, right? And then that would whittle down to the 7, right? So then that would be like a for loop, and then inside would be doing binary search. So yeah, that worked, but that'd be n log n, and we can do better than that, right? We can just get rid of the log n. So let's make use of the fact that it's sorted, right? So we have this array 2, 7, 11, 15, right? And then we'll just say t is equal to 9. Okay. So whenever you see two pointers, usually the way it works is there's one pointer at the start and one pointer at the beginning, right? There's other cases too when like for example, like another effective way of determining whether something is a palindrome is like you start at the middle and you expand on it and you expand around center. That's a useful way to do palindrome. But like in this case, we're just gonna be using the start and the end, right? So how can we make use of the fact that this being sorted can get us to get us to our answer? So like let's look at this, right? So if we add up these two numbers, what do we get? 17, right? Is this number greater than our target? Okay, so this is greater than 9, right? So how can we get this number smaller? Making use of the fact that it's sorted. The decrement what?
Sorry, the pointer from the
Right. Exactly, right? So the way this works, right? Because it's sorted, if we want a smaller number, then if we want a smaller number, then we'd move this right pointer in, right? Because we know that every number to the left of this is less than or equal to this number, right? And the same idea with this. If we want a number that's greater than, so let's say target was, 18, okay, we'd be moving this in, right? But in our case, this target is equal to 9, right? So this is this case. So then, okay, this is greater. Then we move this in, right? Okay, so now we have the number 13. Is this greater than 9 still? It's greater than 9, right? But we made progress. Now we're moving towards the number. So what should we do? Move it in again, right? And now we're at 7. What's 2 plus 7? That's 9. 9 is equal to 9. And then we can return true. Okay? So does everyone understand the algorithm? Okay, so let's write the function. So def, okay, so we're just gonna call it solution. Okay, so what is this taking? This is taking in a list. So it's taking in a list of ints, right? Int and um and okay, it's what is it called? It's called nums, all right? Nums, and then it's also taking in int. I'm just gonna call it t. Okay, so t, and this is returning uh a list, right? So list. Okay. So does anyone have an idea of how we should start this?
So I guess like before we could add the start and beginning where we at.
So yeah, we could do that, but like, shouldn't we just do that in our, because we're gonna have to end up looping the thing, right? So shouldn't we just do it inside? Because then, like, if we do it outside, then we just have to do it again, right? So like let's think about it, right? Okay? What are we adding? We're adding these two numbers, right? But then, what's pointing to these numbers? Those pointers we're talking about, right? So it'd be left and right, right? So we can just, I'm gonna say L. Okay, so L is equal to 0. Right is equal to the length of nums minus 1, right? So our program, so then like you're gonna see, right? So what should we do? Like, when do we want our while loop to terminate? Exactly, right? So okay, so while, so what should it be? Less than or equal to, less than what? So to think about that, right? Because we must choose. So this probably doesn't really say it, but we have to make, so think about it. If we were to, let's say this was, the target was 4, right? Can we choose 2 twice? That'd be one canister, right? So it has to be unique, right? So if we put less than or equals to, it can get to the case where so we just want to do while left is less than, or yeah, while left is less than right, right? So we have that, okay? Now we can just get into adding numbers. So we can just make a variable, right? So we can say, you know, total is equal to nums left plus nums right. Okay. So now what's the first case we should check now that we have the total?
The total greater than your target.
Let's like we can do greater, but let's just do okay. Yeah. Okay. We can start with greater. Right. So if total is greater than t, okay, what do we want to do? Yeah, so if our number is greater, so like 17 is greater than 9, what we want to do, we want to just move in that right pointer, right? So we can get a smaller number, okay? 9 minus equals 1, okay? Otherwise, total, so we can just do less than, right? Is less than t, and what should we do there? Left should go in, right? And I just realized, okay, right minus equals 1, and this would be left plus equals 1. And what's the other case checking? What's the last case? So we have when they're less than or equal to, so less than greater than, so this else would be checking what? If they're equal. And if they're equal, what do we want to do? Well,
Or turn it to
yeah, so what should we put inside this? Yeah. Right. And we don't need to return anything on the outside because there's always going to be exactly one solution. Okay. So yeah, this is fine. This code works, and yeah, I changed up the wording a bit, just to throw some of you kids off. But yeah, this is the question. This is two sum two. It's really popular, uh, and yeah. So does everyone understand this? Yeah, we can move on. All right, cool, cool. So now let's move on to the last problem I have for today. I'll let you guys read it. Okay, has everyone read it? Yeah. All right. I'll just ask. Does this problem look familiar to anybody? Okay, good. That means me changing up the wording works. Okay, so let me. So let's draw a visual example. So do you guys like see? Oh, this is touchscreen. Do you guys see how this is getting 49? Okay, so let's draw this out, right? So we have an array here, right? This is 1, 8, 6, 2, 5, 4, 8, 3, 7, 8, 3, 7. Okay, so the way this is kind of being represented is think of these as like bars. So we can have something like this will represent 1, this will represent 8, this will represent 6, this will represent 2, this will represent 5, this would represent 4, this would represent uh 8, this would represent 3, and this would represent 7. So this is kind of what this is representing, right? So basically our program, what it wants to do is that it wants to find basically the biggest rectangle we can make. Okay, so basically, so in this case, right, it would be, so we're saying index 1 and 8, right? So this would be, it would be these two. Okay, so basically we'd be fine. So basically this program is, so this with this example, we're basically our program is basically gonna be saying, okay, this is going to be, so let's look at this, right? So this is going to be the biggest rectangle we can make with this given input. Okay, this is what this is saying. Okay, so and how is it getting this right? So it's kind of telling you, it's saying it's telling you like how we're doing it. So I kind of put that because I didn't want to put the picture, but because I want to draw the picture. So we have this here, right? So this okay. So this is a rectangle, right? So how do you get the area of a rectangle? Right, length times width, right? So here, what would be the width here?
Towers.
Hmm? So right, it would just be this minus this, right? Right. So that would just be whatever this is. I think what is this? This is so this would be 8 - 1, so this would be 7, right? Okay. So this has a height of 7. Okay. And then oh my bad. So this has a width of 7. Okay. And let's look at the height, right? So we know that height here is 7, right? Because we probably know 7 times 7 is 49. But why are we getting 7 for this height? Like why are we not using 8?
Signal strength of 7 when it reached the top of it.
Exactly, right? Because let's look at this, right? If we let's just say we went to 8, right? Then kind of think of it as like then there'd be this piece over here, right? And that's not valid. We can't have that. It has to be what's shared between them, right? So and you can kind of see it with what I gave you here, right? The minimum of the two. So this here would be height, and this would be the width, right? So this is literally that like this is that type of problem. It's like if you know how to take the area of a rectangle, like this problem shouldn't be that bad. So now we can just kind of combine this with two pointer. But before we talk about the two pointer approach, I want to mention the brute force approach. Okay. So we have this. Okay, so can I erase this? Everyone understand this? Okay. So before we do the two pointers, let's so before okay, so if you're ever like seeing a problem for the first time, um you shouldn't try to just do the like unless you like know it, then maybe you can like just do it from the start and like mention like the brute force way. But if you're see like this problem, like if you're just seeing it for the first time, you should ideally you should do it like the crappy way first. Like because at first having a solution, a working solution, is better than no solution, right? And then you can work with your interviewer to like make it optimal, right? And that's good. That's what they want. So let's just do this the bad way first, or not the bad. Let's just brute force this. So you can kind of this gives a huge hint on like how to brute force it. So does anybody have an idea of what we should do on just how we would get it? So remember how we had the things, right? So instead of moving, so let's think about this, right? To brute forces, can we let's just say we start with this 1 over here. Can we check that to every single possible very way, and then we can go to this 8 and we can check that with every possible thing, 6 every possible thing, this every possible thing. Like, can we do that? Like, that's good, right? That works. So that would literally just be the brute force. The brute force, I'm not gonna even code it out because I feel like that's it's very intuitive, right? I feel like everyone understands what I'm talking about here. Yeah. So right. So like that way we just check every single way, right? So we just check this compared to everything in front of it, this compared to everything in front of it, this compared to everything in front of it, and then we can just keep on updating our max area, right? And then we can return that at the end, right? And does anybody tell me? Can anybody tell me what like the time complexity of that would be?
Like 10 squared.
It'd be n squared, right? Because we're touching every element at least twice, right? So like we have those two nested for loops, so that works, right? And a space would just be O of 1, right? But then because we can make fact, we can use fact. So we can move. So instead of doing it brute force, where we're checking every single possible way, we can kind of move our pointers in smart, right? So let's say we have the 7 and 1, right? So this is where our program is gonna be starting. Okay, when do we want to move in this 1? So we're gonna want to move in this 1, right? Because that's how we're gonna end up to this 8, right? So what is the case that we want to move in? Like, what are we checking and what are we moving in, and why?
If the signal strength to the right or the left is greater than the current.
Exactly, right? So we be considering this, right? Is this 1 greater or less than the 7? It's less than, right? So then we should move it in. Okay. So then it's gonna check 8 and 7. It's gonna compute that. It's gonna be 49, right? Then it's gonna keep on checking. It's not gonna stop, right? It's gonna check 8 and 7. What's the greater of those two? 8, right? So then it's gonna move into 7, and it's gonna compute 8 and 3, and it's gonna move in this. It's gonna 8 to 8, and then it'll just keep on going. Okay. So in this case, it would just be like 6, and it would go until it gets like the middle, right? And it would just be at this middle, and it wouldn't go into, because think about it, if we do less than or equals 2, right? Like what would the width be? Like after at the end of our program, width would just be 0, right? And that, like, there's no point in checking that because anything times 0 is 0. So we can start writing this out. So we can say def solution, right? And this is taking in a list of integers, and it's called signals. Signals, and we don't care about a target. Okay, so, and this will just return an int. Okay, so first thing first, let's just start off our things, right? So we're gonna be returning an integer at the end, right? Like, so we should, and that's gonna be continually updated to our program, right? So we can just say, result, right? Res is equal to 0. So we have that. Now let's define our 2 pointers, right? One is at the start, one is at the end, right? So length of signals minus 1. Okay. So now we have a 2 pointer. So now let's just get into writing our while loop. So you guys might see, right? This, like, those three previous problems we like done, including this, like, they all kind of have the same format, right? Like, they all just look the same, and that's what you're gonna realize. Like, it's like once you understand, like, all the algorithms, some of them just kind of look the same, like, so it's just like, because this is 2 pointer, you can say, oh, and then you have the starting point, right? And then from there you can just kind of tweaking it a little bit just to fit what you need, right? So while left is less than right. Okay. So what do we want to do? So do you guys think, like, so we could break it up, right? So first let's compute the height. Okay. So we can just say, h is equal to, and what would the height be? Like, how would we compute the height? It would be lower of the two, right? So we just say min, and we can say signals, which would be left, and then signals, which would be right. Okay, that would be height. So now let's look at width. Okay, what would width be? Kind of look at this. It'd just be right minus left, right? So, okay, right minus left. So now we know area is just left times right. It would just be height times width, right? So we can say a is equal to h times w. Okay, I'm kind of just writing out like this just to break it down. So now all we have to do, right, is we can just say here. So now what should we do here? So now we have the area. So now what should we do? Think here. Yeah, we should compare the two, right? We should compare what our result is, and we should update it accordingly, right? So now we can just say, res is equal to the max, right? And it should be the max of what? It would be the max of, so it would be the max of a and res, right? Because we're continually updating. So basically, this is saying, hey, if this a is greater, we're going to store it in res, right? If it's not, we're going to keep our current. Okay, our current is fine. Okay, then that's what eventually is going to happen, right? Because then it's gonna compute our 49 with this 8 and 7, and it's going to keep on going, but it's never going to find another greater one, right? So now we have this result. So now let's think about how we want to move in those 2 points. You remember the algorithm we said? If it's smaller, then we move it in, and if it's not, we keep it. So we can say this: if signals left. So if it's less than signals right, okay, what do we want to do? We're gonna move right. We're gonna move what to the right? Exactly. We're gonna move left to right, right? So this will now just be left plus equals 1. And otherwise, we just want to move right in, right? And that would just be right minus equals 1. And then at the end, we can just return our result. And then that would effectively be the program. So does this make sense to everyone? Does anyone have any questions? No? No questions? Okay. So yeah, so it's 101. I didn't even think we were gonna get to these 3 questions because the last hash map one, we only did like 2. But I guess we can just leave this time for like any questions. I can so I if you guys saw like the post or whatever, this summer I'm an incoming software engineering intern at Bloomberg, and like at last event they just like the last 15 minutes or so they just asked me questions about and advice about like interviews and like what to expect in the process and like just anything. So does anybody have any questions on stuff like that? Yes. Oh, but were you following along though? Lavin? Oh, like, did you understand what we were doing though? Okay, okay. Yeah, yeah. So I'm sure like a lot of you have taken wax. Oh yeah, this is the problem. LeetCode. It's really popular. But yeah, have you taken 211 with Waxman? Not yet. Okay, yeah. So next semester it starts getting a lot better. So yeah, 111 this might be a bit too tricky, but if you're able to follow along, then I'd say you're just fine. But yeah, there's no specific like time. You just start LeetCode. Like honestly, you can go home and start it now, right? Like I started it last semester. I hadn't taken 313 yet, and like you don't need a class. Just follow a good roadmap. Like there's these 2 guys that I love. There's everyone probably knows this guy, LeetCode, and then there's also this guy, Algomap. So the way I did it was when I started, which was like last semester, I okay. So when I started last semester, following a roadmap is very important because I'll tell you, like here, I'll just bring up his thing. So you do not want to, if you don't follow a roadmap, you're just gonna end up like, for example, right? Let's just say you get an array question, and then like you like on LeetCode, number 1 is 2 sum, and then like number 2 is like what median of 2 sorted arrays. Yeah, and that's a really hard problem. Like that's so it's just like you can't just go down the numbers, right? Like you should follow a roadmap because these guys like they've done this process before. They know this, so they basically make it so like okay, arrays and hashing, like you need to do this, and once you can like do these, then this is like kind of like this gives you a good base to get onto this stuff. Okay, and then once you do like arrays and hashing, you do 2 pointers and stack, and then once you go from there, you can do binary search, like we mentioned binary search, right? What is binary search? It's just pretty much 2 pointers, right? Left and right, and then you calculate mid, and then you update right and left based on mid, right? And then yeah, sliding window. Sliding window is literally just think about it. Just like you're in an array or whatever, you're like just sliding this, and then you meet a certain condition, you close the window behind you. That's like all sliding window is. And what is that? That's left and right, right? So you see, like this is just built off that. So you should 100% follow just the roadmap. I say start with Algomap. He's a lot more beginner friendly. If you look at his questions, it's a lot more easies and like no hards. But and I'd say like run through this roadmap, do the easies, and then go back, do the mediums, and then from there I'd say, and if you've understood like all the 100 questions he has on his thing, then I'd say do LeetCode. LeetCode is really good for actual like interview prep, like when you're like interviewing for companies and stuff. A lot of companies they just pull their questions straight off his roadmap, or they'll give you a variation, like the questions I gave. These are literally just questions off this list, and I just reworded them. So yeah, so this is like these are really good resources. I'd say check them out. you can start whenever, just learn at your own time. And because like you're like a freshman, right? Like you're taking 111, you have a lot of time. And then when you do take like 313, the higher level course, like you'll be a lot better for it.
How much legal? How much legal problem have you solved? Like comfortably like handle it.
Okay, so I will tell you this. When you're doing LeetCode, don't chase numbers. So in my case, I just kind of kept on doing. So I started mid August and I stopped mid December, and I've done around like 400. But like that's because I had a lot of time, right? Like LeetCode at the end of the day is just like how much time do you have, right? I had a pretty chill semester, so I was able to just grind it out. Um, but I will tell you right now, a good 150, like this Nico 150, if you fully understand, like you can understand and do these, I guarantee you, like you'll be in a lot, like that's way better than like doing 400. That just what this is like if you can do this, like you're ready for new grad. Like this is good stuff, like if you understand these 150 questions, and you can go through this list and like understand and like be able to redo them, then I will tell you right now, like you don't need to do 400 problems at that point. Like you just be doing problems for fun, and that's what it became for me, right? But yeah, so just chase understanding, like the fundamentals, and you'll be in a way better spot. uh but yeah, any other questions? And also, back there, that's the other Bloomberg intern for the summer. So yeah, I guess if you guys also want to catch him outside, you guys can get some answers out of him. Yeah, what's up?
So it's just off the topic. It's like basically, what kind of project do you think like, we should scale or aim for? Let's say to stand out.
Projects?
Yeah, we should show in our one.
Okay, so yeah, I mean, for projects, I'd say, okay, so there's definitely like there's cool stuff you can make, right? Like if you want to make like cool projects, go to hackathons, right? Like you'll always be like working on cool stuff with like cool people. You'll make cool stuff you can put on your resume. But at the end of it, like in my opinion, you should make projects that you find fun, like that you enjoy. Because I mean, like employers, they see that stuff. They don't want just someone, like what would you want, someone on your team who like has a passion and like enjoys doing this stuff, or like just someone who's just there just like really like they want to see the like like you guys are young, right? Like I'm young. I'm not saying, yeah, okay, but like we're young. They want to see like that we're having fun with this. We care about this because I mean at the end of the day, right? I'll tell you this right now. Technical skills, okay, that can be taught. Okay, like no matter who you are, you can learn. Okay, but who you are as like a person, like that's just kind of like how it is, right? You can't really teach an old dog like new tricks, something like that, right? So that's why just be like just like be real, like it's like it makes stuff you enjoy, make stuff like, and if you get users and stuff, you get like cool metrics and stuff, like yeah, put that, that's amazing, right? And that's why like I say, when you're starting, go to hackathons, right? Because you can have stuff like that. Like I have a couple of friends, they literally got scouted by like this Series A startup, and now they're like working for him part-time. They're making like 50 an hour, so it's just like that's cool, right? And they made stuff that was really cool, and they got rewarded for it. So just just have fun with it. It's cool. But any other questions?
How would you go about learning a new language? I know Professor Waxman teaches a Python
Yeah.
class, but he doesn't do it every semester.
Yeah. I mean, to be fair, once you all program language, like once you learn the concepts, it's just syntax. Like a for loop is a for loop in Python and Go, right? Like so it's just learning syntax, and then what's it like? How do you get better with just like yes, you just do it, just repeat, right? That's why I say LeetCode is really good, because LeetCode is just like that, right? You're just gonna be writing code and just be doing problems. So then it's really easy, in my opinion, like to get like if you want to get comfortable with the language, like if you want to like learn, like Java or Go, I say LeetCode is a great place to start. Because then you learn like a bunch of cool little tricks. You learn the ins and outs of like how Java works. How Python works. So I'd say yeah, LeetCode is it's an amazing resource. People always like, like they always crap on it and they say, oh, why do companies ask this? But like we should be happy they ask this, because I feel like how much information can you find out in like an hour? Because interviews are like an hour max, right? How much information can you find out? And this is something you can study for. Like, see, like we can just go through the list, we can do problems, and like maybe you could pray you've seen the problem before and just act like you did it. But that's what this is. Like you have a fighting chance when it comes to like legal. So hey, like balls in your court. Just yeah. But does anybody have any questions on just like my process for Bloomberg?
So can you like briefly like share the timeline?
Yeah. So I you guys are familiar with Code for All, right? Yeah. So Code for All had an event last semester. So and it was Justin, the president. He did really good at his Bloomberg software engineering internship, and Bloomberg was like, "Hey, are there more kids here like you?" And he was like, "Yeah." So he was like, "All right, let's host an event." And then they basically hosted an event. It was just like meeting some of the engineers, like learning what Bloomberg is about. And then basically, if you went to the event, you basically got a special guaranteed link to like get an interview. I think it was 40 people got. I think all 40 got interviews. So yeah, I was lucky to be there, and like I got an interview. Something funny, I applied with like the wrong email in the start, and then I got rejected, and then I applied with the right email, and then I was like, oh, so we were fine. And then so that was September 23rd. First interview was November 5th. After that first interview, I got confirmation like 2 weeks later that I got a super day. And then the way Bloomberg does their super day is like, so it's two technicals and HR for super day. So, but the first interview is just like it's like a technical screen, right? It's just first, it's like 15 minutes behavioral, 45 minutes technical. Okay, and like last 5 minutes is just questions if you have any. Okay, and then after that you have the super day. Super day, the first two are it's the same format as the first interview. It's 45 minutes technical, like 10 minutes behavioral, 5 minutes questions. And then the way Bloomer does it is if you do bad in like any interview, they're just gonna like send you home for the day. Like so they're just not gonna continue. So you have so a good indicator that you like is they're gonna ask you, are you free in an hour? And if you are, then you just get you come back in an hour. You do that interview. So I did those two technicals, and then I had HR. It was just 30 minutes talking, and then after that HR. Well, the HR doesn't really tell you, but like they can. And then after that, I got scheduled for engineering manager round. That was the fifth and final round. And it's just an hour of talking about your projects. You could be like, and it's like talking about your resume, and that's advice I have. Like, know your resume inside and out. Like you should be able to, if I like pull any single bullet point, you should be able to talk about that, expand on it, on your own. Like I don't have to go and ask you questions to pull information out of you. You can just answer them, right? So know your resume inside and out, and just yeah, like that's number one thing. I wasn't asked anything on my resume for my engineering manager. I got like one of the really cool ones who just wanted to talk to me. So yeah, that was really cool. But yeah, that was, and then oh yeah, so engineering manager round was December 18th. Super day was December 11th, and I got my offer January 7th. Yeah. But any other questions?
So is this internship going to be for how long?
11 weeks. So because right now I'm a sophomore, I would be getting like hopefully like a return offer for next summer for intern, and then from there it'd be full time. Yeah. Yeah. And that's what I'm saying. Like if I can do it, like you guys can everything. Like I'm not that smart. like I'm not trying to be like humble or anything. Like, that's why I had to do like 400. So you guys can definitely get away with like a lot less than that. But yeah. Any other questions? Oh, okay. Good.
Can we just give a round of applause to Muhammad?
Thank you.
You can just show them the Learning Commons YouTube.
Oh yeah.